Linear motion, type 5, meeting and colliding. In this question from 2006, question 1b, we have two trains, each of length 79.5 metres, moving in opposite directions along parallel lines. We're told they meet at O and it takes t seconds to pass each other. So if we were to draw a little diagram just to represent this, we have a straight line and we have the two trains. So let's call this P and Q. And at some point they meet, which is 0. And we're told that they are 79.5 metres in length. So therefore the length of this train means that the distance from O to P must be 79.5 and the distance from O to Q must be 79.5 metres. So in other words, if they just pass each other out, the distance is going to be 159 metres. So in other words, if this is S1 and this is S2 and this is D, then we know the key to solving this problem for meeting or colliding is that D is equal to S1 plus S2. In other words, 159 metres. So the first thing we want to do is set up the information we know about train P and train Q. And in question 1, it says find the distance travelled by each train in t seconds. So in other words, we're looking for S1 and S2, but in terms of t. Okay, so what do we know about train P? Well, for train P, we're told the initial velocity is 15 metres per second. We're told that the acceleration is 0.3 metres per second squared. And we're looking for the time in terms of t. So we're just going to say that's t seconds. And the distance that the train travels before they completely pass each other is what we're looking for. So we're looking for it in terms of t. So we'll have S equals ut plus a half at squared. And if we sub in our values, then we're going to have S1 is equal to 15t plus a half times 0.3 t squared. So in other words, S1 in terms of t will be 15t plus 0.15 t squared. So that's our distance for the train P in terms of t. Okay, so we need to do the same for the second train. So for train Q, so again, we write down what information are we told about train Q. So we're told train Q has an initial velocity of 10 metres per second. The acceleration is 0.2 metres per second squared. And our time t, again, is going to be in terms of t. And the distance that it travels during any time can be found then in terms of S equals ut plus a half at squared. So in other words, at any stage in the journey, its distance travelled will be represented by this equation. So we'll have S2 is equal to ut plus a half at squared. So of course, if I simplify that, S2 will be equal to 10t plus 0.1 t squared. So that allows us to find at any stage in the journey the distance travelled by either train P or train Q. So that is part 1 done. So it then says in part 2, hence or otherwise calculate the value of t. So the otherwise could be any other solution that you come up with yourself, but if it's saying hence here, I'm going to use the information that I have. And as I said earlier at the start, if we look back up to the top right hand corner, the key to our solution for meeting and colliding is that D is equal to S1 plus S2. In other words, 159. So we're going to equate those two equations. So we're going to use the fact that D is equal to S1 plus S2 to solve our time, where D is equal to 159 metres. So in other words, when P passes Q, and Q passes P, the distance they will have travelled together is 159 metres, the length of each train combined. So we'll take S1, which is 15t plus 0.15t squared, and I will add that to S2, which is 10t plus 0.1t squared, and that must equal 159. So simplifying that, we end up with 0.25t squared plus 25t is equal to 159. And if I bring everything to one side and divide across by 0.25, we end up with a nice neat quadratic. So we end up with t squared plus 100t minus 636. Now you can, of course, leave it in terms of 0.25t squared and just go to your minus b formula. It doesn't matter how you solve your quadratics as long as you are solving them correctly. But if you spot a nice neat quadratic, sometimes this is easy to factorise. So if I'm looking at that there, my factors of minus 636 are 106 and minus 6. So if I sub that back in, we have t squared plus 106t minus 6t minus 636 equals 0. And if I group the first two, group the second two, take out your highest common factor, we end up with t times t plus 106 minus 6 times t plus 106 is equal to 0. So our two factors are t plus 106 times t minus 6 equals 0. And of course, if I let both of those factors equal to 0 and solve, I'll end up with t equals minus 106 seconds, which isn't possible because, of course, we can't have negative time, or t is equal to 6 seconds. And of course, that's our answer. So the time taken for the two trains to pass each other then is 6 seconds. Okay, so if we go back up to the last part of the question, then it says, how long does it take for 2/5 of the length of train Q to pass point 0? So 2/5 of length Q is 2/5 of the length of the train, in other words 79.5 metres. So in other words, S2 is going to be equal to 31.8 for this part of the question. And we also know that S2 is equal to 10t plus 0.1t squared. So by letting 10t plus 0.1t squared equal 31.8, what we can do then is, again, rearrange that quadratic and divide across by 0.1. Again, we're going to end up with a quadratic to solve. This time, we're not going to get nice neat factors, so we will use the minus b formula. So we'll have a is equal to 1, b is equal to 100, and c is equal to minus 318. So if we're subbing that into our minus b formula, we have minus b plus or minus the square root of b squared minus 4ac all over 2a. And if I'm subbing my values in, that gives me minus 100 plus or minus the square root of 100 squared minus 4 times a times c all over 2a. So of course, subbing that into your calculator, we'll end up with two values, and we're only going to take the positive value here, which is 3.09 seconds. Okay, so if we look at the mark, so we had 5 marks for the last time. And if I go back to the previous page, we had 5 marks for getting S1 and S2, so our two equations in terms of t for the distance travelled by train P and train Q. We had 5 marks for our relationship that d is equal to S1 plus S2, and we had 5 marks for t is equal to 6 seconds. Okay.